Hi everyone. So in this video, we are going to discuss few exercise problem from chapter 11 of your NCERT, that is dual nature of radiation and matter. So the first question is 11.1. Find the maximum frequency and minimum wavelength of X-rays produced by 30 kilovolt electrons. Find the maximum frequency. Okay. Now energy of the electrons is 30 kilovolt. Okay. 30 kilovolt. Okay. Now this is 30 kilovolt means 30 into 10 power 3 volt. Okay. Now energy is given in terms of potential. So how to convert this into energy of electrons? So energy, it will be equal to charge times potential. Now here the charge is electron. We are talking about electrons. So E into V. Okay. So what is E? E is 1.6 into 10 power minus 19 into potential 30 kilovolt. So 30 into 10 power 3. So 30 into 10 power 3. Okay. This much joule. Okay. Now this is energy E. And this energy E. Okay. Now energy, it is also equal to h nu, where nu is the frequency. Okay, so that gives nu is equal to E by h. So where E is this quantity 1.6 into 10 power minus 19 into 30 into 10 power 3 divided by Planck's constant. Planck's constant. So that is 6.6 into 10 power minus 34. Okay. Now this on simplification gives nu is equal to 7.2 into 10 power 18 hertz. Okay. So this is the frequency. Okay. Now then it is asked. So this is the maximum frequency. Okay. Now E is equal to h nu is equal to h c by lambda. Nu is c by lambda. So if this frequency is the maximum frequency, this corresponding wavelength will be the minimum wavelength. Okay. So we can use this result to determine the minimum wavelength. So frequency nu is equal to c by lambda. So this gives lambda is equal to c by frequency. So that is 3 into 10 power 8 divided by 7.2 into 10 power 18. So this on simplification gives 0.4 into 10 power minus 10 meter. So that is equal to 0.4 angstrom. Okay. So this is the minimum wavelength. Okay. Corresponding to this maximum frequency. So in the next question, that is 11.2, we have the work function of cesium metal is 2.14 electron volt. When light of frequency 6 into 10 power 18 hertz is incident on the metal surface, photo emission of electron occurs. What is the, now there are two parts of the question. First part is what is the maximum kinetic energy of the emitted electrons and what is the stopping potential. Okay, so that means we have to find K max, that is the maximum kinetic energy, and stopping potential, that is denoted by the symbol V naught. These two quantities are required. And what is given? Work function is given. Okay, work function phi, it is 2.14 electron volt. Okay, so what that is 1.6 into 10 power minus 19 joule. Okay, so I have converted work function into joule. That is, work function was given in electron volt, so I have expressed in joule. The frequency, it is given as 6 into 10 power 14 hertz. Okay. Acha. Now let us use the Einstein's photoelectric equation. Okay. So Einstein's photoelectric equation is Ek max or K max, that is the maximum kinetic energy. It is equal to h nu minus phi. Okay. H nu minus phi. Now this is equal to, see, h is 6.6 into 10 power minus 34. Then nu is frequency is 6 into 10 power 14 minus 2.14 into 1.6 into 10 power minus 19. Okay, so this is the work function, this quantity. Okay, now this is K max. Okay, now suppose you have to express the answer in electron volt. Okay, if you wish to express the answer K max in electron volt, then what you do, you divide the entire quantity with 1.6 into 10 power minus 19 coulomb. Okay, you have to divide the entire quantity by 1.6 into 10 power minus 19. Okay, so if you divide, this gets cancelled. Okay, and here you will have 1.6 into 10 power minus 19. Okay, now this quantity, now it is in electron volt. Okay, so now if you simplify this, okay, if you simplify this, you will get the result as 0. Is equal to 0.3 volt electron volt. Okay, so this is the maximum kinetic energy. Okay, now what is the advantage of expressing the answer in electron volt? Because now we got K max. Okay, now this is K max, this is K max. Now K max is equal to EV naught. Okay, so that means this E, that is charge of electron, and this is charge of electron, gets cancelled. So we got the stopping potential V naught is equal to 0.34 volt. No calculation, direct answer, katak. Okay, so this is the second part B of the question. Now next question is a similar question, like the photoelectric cutoff voltage in a certain experiment is 1.5 volt. So that means this is the stopping potential V naught, it is equal to 1.5 volt. Okay, what is the maximum kinetic energy of the photoelectrons? Okay, so K max, it is equal to EV naught. Okay, K max is equal to EV naught, so that is 1.5 electron volt. Okay, so directly you can do. Okay, so this is the relation between maximum kinetic energy and stopping potential. Okay, and this is potential in volt. We have expressed maximum kinetic energy and electron volt. That's it. Okay. So in this question number 11.4, we have monochromatic light of wavelength 632.8 nanometer is produced by helium neon laser. The power emitted is 9.42 milliwatt, small m capital W, that is milliwatt. If it is capital M capital W, okay, it will be megawatt. Okay, so find the energy and momentum of each photon in the light beam. Okay, so part A, we have to find energy and momentum. Wavelength is given. So what is energy? Energy is equal to hc by lambda, isn't it? So this is 6.6 into 10 power minus 34 into C, 3 into 10 power 8 divided by lambda. So lambda is given to be 632.8 nanometer. So that is 10 power minus 9. Okay. So if you simplify this, you will get E is equal to 3.14 into 10 power minus 19 joule. Okay. Now then it is asked momentum of each photon. Now from de Broglie relation, we have lambda is equal to h by p. So that gives P is equal to h by lambda. Okay, lambda is given, so P, it is equal to 6.6 into 10 power minus 34 divided by lambda 632 nanometer, so 632.8 into 10 power minus 9. Okay, so if you simplify this, you'll get this result as 1.05 into 10 power minus 27. Momentum unit is kg meter per second. Okay, kg meter per second. So this is momentum and this is energy of each photon. Okay, so this is part A. Next, proceed to the part B. So part B, we have how many photons per second on the average arrived at the target. That is number of photons per second. Okay. Now that is number of photons per second. It is nothing but power, total power divided by energy of each photon. Okay. Why it is total power divided by each photon? See, power is total energy emitted by all photons per unit time. Okay, per unit time or per second. And this is energy of one photon. Energy of one photon. So this is the total energy of all photons. So if you divide this, you will get the number of photons that are arriving per second. Okay, so power is 9.42 milliwatt. So that is 9.42 into 10 power minus 3 watt divided by energy of one photon that we have already calculated in the previous part of the question, 3.14 into 10 power minus 19 joule. Okay, so if you simplify this, you'll get the result as 3 into 10 power 16 photons per second. Okay, so this is the answer to part B. Now for part C, it is asked how fast does the hydrogen atom have to travel in order to have the same momentum as the photon. Okay, now momentum, it is mass into velocity. Okay, so velocity is equal to momentum divided by mass. Now this momentum is the momentum of the photon and mass will be the mass of the hydrogen. Okay, now momentum we have already calculated in the previous part, so that is 1.05 into 10 power minus 27. Mass of hydrogen, that is 1.66 into 10 power minus 27. Okay, so this gets cancelled. So this, if you simplify, you will get V is equal to 0.63 meter per second. Okay, so the hydrogen atom must move with the speed of 0.63 meter per second if it is to have the same momentum as that of the photon. Okay, so this is the answer to the part C of the question. So in this question 11.5, we have the energy flux of sunlight reaching the surface of earth is 1.388 into 10 power 3 watt per meter square. So this is basically energy per unit time per unit area. Okay, how many photons per square meter are incident on the earth per second? Assuming that photons in the sunlight have an average wavelength of 550 nanometer. Okay, so first let us calculate the energy of one photon. Okay, energy of one photon, energy of one photon. So that is E is equal to h c by lambda. Wavelength is given, wavelength of the photon. So this is 6.6 into 10 power minus 34 into 3 into 10 power 8 divided by wavelength is 550 nanometer. So that is 550 into 10 power minus 9. Okay, so this is the energy of one photon. Okay, if you simplify this, you will get the result as 3.6 into 10 power minus 19 joule. Okay, now it is asked number of photons. how many photons per square meter are incident. Okay, the energy flux is already given. From the unit itself, you can directly say, if you divide this quantity, that is energy flux, with the energy of one photon, you will get the total number of photons, that is how many photons per square meter are incident, isn't it? So this is so n, it number of photons, it will be equal to 1.388 into 10 power 3. Okay, this is, see, watt per meter square, that is energy per second per square meter. Okay, and this is the energy of one photon. So this divide by energy of one photon, so that is 3.6 into 10 power minus 19. Okay, so if you simplify this, you will get the answer as 3.8 into 10 power 21. Okay, these many photons per square meter. Okay, but in the your NCERT, the answer is given to be 4 into 10 power 21. That is, they have approximated this to be 4. Okay, so this is your final result. So you can write any one, because for approximation, you are, means if you approximate, or even if your answer is means near to the actual answer, means if it is 4 and after calculation you are getting 3.8 or 4.2, you will get full marks. You will not, no marks will be deducted.